Okay, good afternoon, everybody, and well, thanks a lot, Martha and DSA, for inviting me today and for giving me the opportunity to give a presentation right before that very distinguished panel of experts that will follow. So yeah, let me talk a little bit about the enterprise use cases and applications that are enterprise aspects of spectrum sharing and spectrum management. Right. Okay. So, well, this is all about spectrum, verticals, and enterprises, and dynamic spectrum sharing, and so on. So let me start with looking at what is a vertical, because we hear a lot about verticals. So vertical is typically a company or public sector organization which operates in a specific sector. So, and I have a list of sectors here, from manufacturing over healthcare to public safety, etc. So all these sectors are actually addressed with I would say enterprise network solutions. And as Martha said, HPE, we are providing solutions and enterprise networks for all these sectors and to satisfying their connectivity needs. So I'll speak mostly about enterprises and enterprise networks from now on, not so much about verticals. So a couple of questions or key questions I would like to address is now, what do enterprises need spectrum for? How much spectrum do they need? And how can they actually benefit from spectrum sharing? So looking at enterprise connectivity, as you saw, there's so many different segments or sectors in the enterprise space, and there's an even larger number of use cases, very diverse use cases, very different requirements and needs. So enterprise networks, I mean, it's a very broad, typically the ecosystem providing enterprise networks is also very wide. So variety of different companies that are providing enterprise networks, and also a variety of technologies being used. Wi-Fi, obviously, mobile, and all kinds of other technologies like Bluetooth LE, Zigbee, now ultra-wideband, which are increasingly being integrated in enterprise networks and even in access point directly to provide IoT technology. Now, Wi-Fi, obviously, we have heard a lot we've heard a lot about Wi-Fi today, and Wi-Fi is, of course, the most popular and most prominent wireless connectivity technology for enterprises. I think there's hardly any enterprise, I would say, that does not use Wi-Fi. If you look at statistics in Europe, I think it's 94% of enterprises are using fixed fixed access to connect to the internet, and also the majority of those enterprises are using Wi-Fi. Well, Wi-Fi is dominant, definitely. We are seeing, I would say, a trend also to introducing private local 5G networks in particular. During the past years, we've seen those networks, P5G networks, gain some traction. As many other companies here in the room, HPE is, say, present on both the Wi-Fi side and the 5G side, because for us, it's of course important to deliver the solutions that are most useful for our customers. So what we see is that in the future, there will increasingly be hybrid Wi-Fi private 5G networks to address different aspects of the enterprise network. Now, let me just go a bit more into the spectrum needs subject. So what are the enterprise spectrum needs? Of course, it very much depends on the use case, but we are very much into high capacity deployments. So where actually you need a lot of spectrum, and what we see is in countries where the full 6 gigahertz band is available for Wi-Fi, and particularly in the US, there's really been a surge of deployments in universities, for instance, in stadiums and arenas, and large hospitals. So all the use cases where you need a lot of non-overlapping channels, a lot of capacity, you need to be able to provide high per user throughputs, low latencies. If you look at the stadium case, for instance, you have to be able to deliver let's say, very high-speed upload capabilities to tens of thousands of users simultaneously. Also, in large hospitals, you need, let's say, a variety of services, and you need a layered approach to use different bands offering different services. All these examples are brought up here: universities, stadiums, arenas, and large hospitals. Of course, also use Wi-Fi for their site administration, operations, and other functions. Now, why is spectrum sharing important for enterprises? Now, what I would say is actually that only by sharing the spectrum resource that enterprises need can be provided in a way that is technically and economically feasible. We've seen that cost, of course, is a very important, probably the most important factor there. Wi-Fi being the most prominent technology in that field and the backbone of wireless enterprise connectivity is designed to share by default. So it shares spectrum with other users in all the bands it's using here, 2.4, 5, and 6 gigahertz. So the LPI and VLP Wi-Fi can share spectrum with incumbents without any further measures. So it has been designed for that. If you look at standard power Wi-Fi, it can also share with incumbents through automated frequency recognition, AFC. So that means actually that the capacity that is delivered through Wi-Fi essentially comes for free because it's overlaid over the existing usage. One important fact I would like to stress here is actually there is no underutilized or unused Wi-Fi band. That's one thing I think that regulators should always keep in mind. They talk about giving spectrum to Wi-Fi. It's not really that you take away something from some service and give it to Wi-Fi. Wi-Fi comes on top of that. Now, enterprises, you can say, have a lot of spectrum. Do they need even more? Why do they need more spectrum? Well, we see that industry and society overall are being digitalized. We have in Europe or with the European Union, we have a digital decade program, which highlights the importance of bringing ever faster connectivity to enterprises through fiber, and then that has to be extended, of course, through Wi-Fi. Now, Wi-Fi that is easily and affordably available, that's becoming increasingly scarce. So we're talking about low and mid-band spectrum. But on the other hand, we have lots of spectrum that is still underutilized or unused. Mostly that's the spectrum that has been licensed for exclusive use by IMT wide area networks. Now, as mentioned before, we see a need also for IMT networks in the enterprises. So there are a number of enterprise use cases that can benefit from IMT, but then spectrum is needed only locally, not on a wide area basis. And anticipating that demand for capacity, many administrations have taken steps to provide that capacity, both for Wi-Fi and for private 5G. And let me give you a few examples from the US, from the UK, and also from Germany. The good thing is, as I said, on the following panel, we have experts from these three countries. And if I say anything wrong here, then they will be able to correct me, of course. Just quickly, the example, of course, in the US, you have licensing exempt use for enterprises. You have 2.4, 5, and the full 6 gigahertz band available. And you have also standard power available there. Then you have CBRS with, let's say, field sharing approach using spectrum access system with databases and sensing. In the UK, you have license shared access in various bands, including the 3.8 to 4.2 gigahertz band. So, which until now works by individually assessing, let's say, requests for licenses and then by licensing those. Germany took a slightly different approach, I would say, by setting aside 100 megahertz of spectrum in the 3.7 gigahertz band. Dedicated spectrum doesn't mean there is no other usage in that band. And also in Germany, that spectrum is individually say assessed and licensed. Now, this is the only picture in my presentation, I'm afraid. So there were so many fancy presentations with images before, so this is mostly text. But this just gives an overview of, let's say, the bands that are currently available for private and local mobile networks. Not only EMEA, the chart shows a comparison with other countries. In Germany, in Europe, you have about 14 countries that have proposed to implement local licensing models, but there is no real harmonization. And internationally, there is no real harmonization, as the image shows. And also in Europe, there's, I would say, like a bit of a patchwork. Although there is some hope for the 3.8 to 4.2 gigahertz band emerging as a potential harmonized band. There is a mandate by the European Commission running since 2021, and the CPT is developing conditions for the 3.8 to 4.2 gigahertz to be used for medium and low power local networks there. Some countries like Switzerland have decided to go a different route, but overall, I think this is really a step in the right direction on the way to harmonization. In MEA, so Middle East Africa, there are some activities in the Emirates, in Saudi Arabia, and also in Qatar, but there are different approaches taken there. Bahrain allowed private local networks in the 3.8 to 4.2 gigahertz band. Well, Qatar, for instance, encourages that the big MNOs are operating these local networks. Now to everybody's favorite subject, what we've heard that before, but I have to talk about the upper 6 gigahertz band and the sharing, let's say, activities and efforts in Europe. So as you know, there's a project team PT1 of the ECC that is working on these studies, and the objective is, of course, to make the upper 6 gigahertz band usable by both Wi-Fi and IMT in a way that both technologies can work as intended. The question is it feasible? We don't know yet. The studies are still going on. We are discussing various sharing options, but of course, one thing which is clear is that both IMT and Wi-Fi must be treated on an equal basis, because there's no priority for IMT, as we know, despite the IMT identification. The other question that I think everybody has to ask themselves is, does sharing make sense? That's also an open question here. We were looking at, as we said before, 90% of data traffic being transferred over Wi-Fi and 10% over mobile. So how do you consider that in sharing? Does it really make sense to share that band? Again, as said here, sharing should not be an aim in itself. It should really provide tangible benefits. And what is being discussed is providing indoor connectivity from macro outdoor base stations operating at high power, which, to be blunt, is not a prudent idea. It's just really a waste of energy and not sustainable at all. One thing to be considered as well when talking about sharing of this band is that enterprises need predictability, both in technical terms but also financial terms. You have to be sure as an enterprise that your investment is secure. You cannot set up, let's say, an enterprise network like in a stadium, which is a huge investment and effort. If you do that, you have to make sure that in 5 or 7 or 10 years from now, you can still use all the spectrum. Because enterprise Wi-Fi, as most people here know, of course, is not like consumer Wi-Fi. You have QoS requirements, you have to deliver a certain performance, per user throughput, and latency and availability, etc. And you cannot just, say, risk that a few years from now, IMT will show up and then just you lose a couple of 100 megahertz of capacity. Right. Okay, going very quickly to a summary and in conclusion. I think everybody agrees that sharing is a good thing, and spectrum resources are scarce and should be used as efficiently as possible. But again, every scenario has to be assessed carefully. Again, sharing should not be, let's say, done just for the sake of sharing. Then harmonization of license spectrum for enterprises is complicated, as shown on one of the previous slides, because of the very different availabilities of spectrum. Harmonization of license exempt spectrum may be easier, especially in the 6 gigahertz band. We've heard that before. The lower 6 gigahertz band is essentially harmonized globally, and the upper 6 gigahertz band is already available in many countries, so it would be easier. And then just to repeat what also many speakers before me said, regulators should focus on actually exploiting the strengths of complementary technologies. That means In the case of IMT and Wi-Fi, for instance, IMT is better used for mobility and outdoor coverage. Wi-Fi is for indoor coverage. So combine both, make sure that, or encourage actually that you adopt mechanisms such as seamless handover, seamless interworking between Wi-Fi and cellular, which would make sense also from a sustainability standpoint, and it would provide more user benefits than having competing and redundant networks, which actually would be a waste of resources and energy. That should be, in my view, discouraged. Well, thank you very much.